You might already be familiar with the concept of an inverse property. For example, with multiplication, numbers which are inverses of each other can be multiplied to produce the identity value of multiplication. Here, 4 and 1 on 4 are inverses of each other and produce the multiplication identity of 1. In some sense, you might think that they undo each other's values. Here we're going to look at inverse functions. Inverse functions are functions which can undo each other's actions on an independent variable or input variable. So informally speaking, a function takes an input and turns it into something else, some other value. An inverse function takes that something else and turns it back into the original input. This inverse function is going to be a specific thing for any function that you start with. What we're going to find in this video is how to check if something is an inverse of another function, and also how to figure out what an inverse is if you don't know. This property is often useful if you're trying to solve equations that involve an independent variable or an input like x, which has been acted upon in some way by some other function. To undo that function, you'll need to know what the inverse function is. So a little bit more formally. So we have a pair of functions, f and g. If those two functions satisfy the property that f of g of x and g of f of x are equal, and more so that they're equal to x, then f and g are said to be inverse functions of each other. In other words, f undoes g to give back x, and g undoes f to give back x, the final result. We actually usually write this with this sort of notation, an f to the minus 1. Now don't think of that as f to the power of minus 1. It's a different concept. We still call it an inverse like we would with regular numbers, but it's a different thing altogether. And remember that the key property is that the functions will undo each other's actions and give us back an x. Another reason we might say that this property is useful is because if we know a function's inverse function, we can determine the input that produced any output value that we're interested in. So for example, we could figure out the time at which a particular function value, or number of bacteria for example, or a particular wave height was given to us. Before we actually look at finding an inverse function, let's see if we can check or verify that two functions are inverses. Here we're asked to show that f of x and g of x are inverse functions of each other. To do this, we need to go back to the definition, which says that f of g of x must be equal to g of f of x, and they must both be equal to x. Pause the video now and have a go at this one yourself. Figure out what f of g of x is, g of f of x is, and show that they're equal to x. First, we have f of g of x. Well, this just means the f function, but replace all of the x's with g. So we have 2 multiplied by the g of x function, which is the cube root of x plus 1 over 2, raised to the third power, and finally take away 1. We can simplify this if we note that we have a cube root raised to the third. So we have 2 times x plus 1 over 2, because the cube root and the third power knock each other out. Again, minus 1. We can cancel the 2's, and we see that we've got x plus 1, minus 1, and finally the plus 1 and the minus 1 knock each other out to give us that f of g of x is equal to x. Okay, you've seen me do one now. If you haven't already, try to figure out what g of f of x is. Take a couple of seconds for that for yourself. Alright, so again we're just going to take the g function and replace all of the x's, there it is right there, with f of x, 2x cubed minus 1. So we have the cube root of 2x cubed minus 1 plus 1 all over 2. The 1's cancel. Into this line the 2's cancel. We're left with the cube root of x to the 3, which is of course x. So finally we have exactly the property we need. F of g of x is equal to g of f of x is equal to x. So f and g are indeed inverse functions of each other. So that's how to check if two functions are inverses. What about actually finding one? Well, first of all, we need to know if one even exists. They don't always exist. Remember that functions must pass the vertical line test, We've seen that when we were checking whether something was a function. In other words, a function must have only one value in the range for each value in its domain. So for a function to have an inverse, the inverse must be a function itself. And that means that the original function must pass as well a horizontal line test. Have a think about this for yourself for a moment. This is one way to check if we can get an inverse, but think about it. Why is that the case? Why do we need it to pass a horizontal line test? Now let's have a look at the process of finding the inverse function. First of all, we're going to check if this function does have an inverse. Well, a square root function essentially looks something like this. So we can imagine doing a horizontal line test on this one, and we'll only ever cross that function at one point for any given vertical axis value. So yeah, we're pretty sure that it's going to have an inverse. But how do we find it? Basically, the process goes by interchanging the x and f of x. Now here what I'm going to do, just to make it a bit neater, is call that y. So we're going to interchange the x and the y, and then try to resolve for y again. So we're going to set x equal to the square root of 2y minus 3. Then we're going to try to solve for y. And to get rid of that square root on the right, I'm going to square both sides. So we'll have x squared is 2y minus 3. Still trying to get at the y, I'll remove the 3 by adding a 3 to both sides. So x squared plus 3 is equal to 2y. Now finally, we need to get rid of the 2, so we'll divide both sides by that. We find that y is equal to x squared plus 3 all over 2. It's this function, which I'm now going to call g of x, or if you prefer, f inverse of x, which is the one that will give us the correct property, that g of f of x is equal to f of g of x is equal to x. Now you can check that one for yourself, or you can just take my word for it, but it's probably better just to have a check and make sure that you get those properties satisfied. So that's it for inverse functions, figuring out if two functions are inverses and figuring out what the inverse is if you don't know. Have a bit more of a think about why you might want an inverse function. What use would it be? Once you've finished thinking about things, maybe writing some things down, try the worksheet problems for the video. As usual, write down your notes in your notebook about things that you want to ask, and perhaps even in your cheat sheet, write down things that you might need to know, such as instructions for finding the inverse.